Hello everyone, I am Naman. I am a student of BSc Honours in Data Science and Artificial Intelligence from IIT Guwahati. I am also pursuing BTech from Computer Science and Engineering from Technological Institute of Textile and Sciences, and I am currently working as a business analyst at India Shelter Finance Corporation Limited. My project for 7th trimester is pixel and bit level image encryption technique. First of all, what is image encryption? Image encryption simply means hiding the important part or particular part of or entire image from unauthorized access so that no unauthorized authority can access without our permission or without accessing the decryption key. And there are two types of encryption. One is pixel level encryption and another is bit level encryption. What is pixel level? Pixel level simply means we either shuffle the pixel throughout the image so that no can understand what's inside the image. Means basically we scramble all the pixel, or we simply change the color values or invert its pixel values. And bit level image encryption technique, it includes manipulating bits of each pixel, and each pixel contains generally 8 bits channel. So we generally manipulate bit level, means we either XOR bit values or perform AES operation or DES operation according to our need, so that no one can analyze the pattern of decryption and cannot decrypt it without the decryption key. Let's take a demonstration. So this is our dashboard, so we can enter the username and password. We can register here also. Test case 2. Email is optional, so we don't have to enter it. Create the password. We can provide the reason for why we are using this project. So academic project and professional work, register. So there are three types of technique. One is standard signography, chaotic encryption, and neural network. Currently, bit plane slicing and DNA encryption are in beta version. I'm currently working on that. So I will show them in next trimester. So first of all, go through chaotic encryption. It is a type of pixel encryption technique. Other two are bit level encryption techniques, standard steganography and neural network encryption. First go through this. In chaotic encryption, how it works. Suppose this is our image. This complete our. There are mainly three types of pixels. One is sky blue pixel, another is red or we can say maroon, or another is yellow. What this method do? It scramble the pixel throughout the image. Suppose this red pixel scramble through this location, yellow pixel scramble through entire image randomly, and sky blue pixel also scramble through the image randomly. It uses mathematical equations to perform operation. Let's take an example of this. Suppose there are many types of pixel: black, blue, sky blue, yellow, white. So all the pixel shuffle throughout the image so that no one can see that what the actual content on the image is. Let's take a demonstration. We can choose the image. Suppose we take this image. There are three types of map. These three types of map work with different mathematical equations, so they scramble the pixel in different order. Let's select logistic map. We can provide encryption key, which is optional. If we don't provide it, auto generate the key. Let's encrypt it. So we can see that. Let me zoom in the image. First we download the image. We can see the pixels are completely shuffled throughout the image and we cannot understand what the actual content was. Let's take another image so that we can clearly identify what's going on. Now in this image we can see there are mainly three types of pixel: white pixel, blue pixel and black pixel. So we encrypted and all the pixels randomly shuffle throughout the image. You can see. Let's download it and copy the key. Now you can get the idea what's going on. There are blue pixel, black pixel and white pixels completely shuffled throughout the image. Number of pixels are same but they are randomly placed in the image. Henon map also work the same but it scramble in different order. Let's see how it different from this. We can see that image changes. Copy the key. Henon maps also scramble the pixel but in different order. All the pixel randomly shuffled and in different order because they use different mathematical equations. Arnold cat map also work in the same way. Let's decrypt our image. This is decryption section where we upload our encrypted image which we have downloaded. So go to download. This image we downloaded and copy the key. We copied. We can paste the key here and click on decryption. Okay, we did not choose the right algorithm. Here is Henon map and here is logistic map. So we can select Henon map, then key is the same and we can decrypt it. Now see, we got the actual image. Now we can download it. The actual image we got. Also we can see our operation history which we performed. We performed these 3 operations. Algorithm also mentioned, key is also mentioned, and we can also download from here also. Same like all other things, we can also delete the record if we don't want them. So this is how chaotic encryption method works. It randomly shuffles all the pixel values according to mathematical equations. Please note that it does not change quality or resolution of the image. Now let's dive into standard steganography. It is a bit level encryption technique. It works differently from chaotic encryption. How? We have to upload 2 images. One is cover image and another is secret image. How it works? Let me show. Suppose these are 2 images. This is our cover image and this is our secret image. How it works? The secret image hide behind the cover image completely and we can only see the cover image, not the secret image which is behind that image. How it works? Let me show you. We know each image has 8-bit pixels. Each pixel have 8-bit value. Let's see this. 1 2 3 4 1 2 3 4. The first one is our most significant bit, and then so on 1 2 3 4 5 6, and last is our least significant bit. What does it mean? The most significant bit refers the actual information of the image which we see with our eyes, and least significant bit or other 7 bit generally contain the metadata like location where the image was captured, or size, or aspect ratio, or date and time, etc. So these values that generally do not appear on the image, or we cannot see these values. We generally see 99% of the time we see the MSB which is showing on the image. Let's take an example. Suppose this is our cover image and this is our secret image. We can also provide key if we want. So let's provide any key 1 2 3 4. Click on hide. You can see that this image is completely behind that image. We cannot see the car image. We can simply copy and download the image. We can see it is a normal image just like as original cover image. Nobody knows that another image is hide behind that image. Let's decrypt it or reveal the image. Downloads. This is our image. So provide the correct key. Now we can see the car image is we got from this image, means the car image actually behind that image. Now you might have a question that their aspect ratio are different. Suppose these are the aspect ratio, this is in landscape aspect ratio and this is in portrait. So how it actually hide behind it? As we can see, it is visible, so it's visible from our perspective, but when we encrypt, it generally resize the image. Resize means it generally zoom in the image. Now we can see that the image is completely behind that. We cannot see secret image from this side. We generally just we resizing the image. We are not in improve, I mean increase the image size or aspect ratio. We just resizing it, means we are zooming it just. So this is how it works. We can also track operation history here. We can download the hidden image and copy the key, and whenever you want to again use that image. So this is our image. We can paste the key and reveal the image. We got originally. We can download it from here. Also, I want to justify one more clarification. Suppose this is our secret image. No, sorry, this is our cover image. Let's write cover. This is our cover, and let's take our secret image. It also has 8-bit pixel values. 1 2 3 4 1 2 3. This is our MSB, and this is our least significant bit. This one. We generally replace the least significant bit of cover image with most significant bit of our actual image or secret image. Now this goes through here and we remove its least significant bit, which we do not see. I mean, as I mentioned that we generally see the most significant part of the image when we see an image. Let's take an example. Suppose we are seeing this image, this car image. We actually seeing the most significant bit of this image, and other bit like first bit, second bit up to least significant bit. These bits generally store its resolution, quality, or date and time capture or other metadata. We only see the most significant part every time when we see any image. So as we cannot see the least significant part of the image, we just replace the most significant part of secret image. Means as how we did that, we replace this image most significant part with this image least significant part, so that we actually do not see what's behind that image, but actual content of this image is already present at the end of image. And when we decrypt the image using Fernet, which is a method in cryptography library of Python, it analyzes the pattern which was used to store this bit at this place. Then it again reverses the process and show us the least significant part of cover image, means that was most significant part of secret image. That's how standard signography works. And all the operation history stored in MongoDB database I will show you later, and all the images stored in Cloud.io I will also show you later. Now this is neural network. It is completely different from other two methods, although it's also a bit level encryption technique. Let me show you how it works. Suppose I give an image to the system. There are two tree priority machines, which are TPM. How it works? Suppose this is machine A, this is machine B. These try to XOR the pixel value. What XOR means? XOR. It simply means if pixel bit value is 0, then it convert it to 1, and if 1, then convert it to 0. They both perform XOR operation, but in different in different order. Suppose machine A starts from, suppose the image I uploaded is this, and machine A start from encryption from this pixel, this yellow pixel, and machine B start from this blue pixel. They XOR the pixel value, like if the value is 0, then it convert it to 1, and if 1, then it convert to 0. They start from encryption this side, and the machine B start from encryption from this side. At a time they meet the pattern in which they are encryption, although they are encrypting or XORing the value in different manner. And but after 100 iteration, although I have implemented 100 iteration, so after 100 iteration they meet the exactly same order in which they encrypt, and we just combine both the methods till 100 iterations. That's how it works. Simply inverting the value. Let's take a demonstration. Let's take this image first. We can provide any key if we want. Let's say 1 2 3 4 5 encrypt. Now we can see that the image is completely encrypted and we cannot see actual data on it. Means all the pixel values are performed XOR operation. Although it's not single time XOR operation, it can be multiple time XOR operation. And when we XOR a pixel value 2 times, it generally gives us the same value. Again XOR, then it show us the original result. That's how it works. It does not mean that all values are XOR completely. Some are restored also. That's how this method works. Now we can decrypt it also. Downloads. This is an encrypted image. Provide the correct key. Now we can see that we got the original image as we want. This was our original image. Decryption only use the reverse process as exactly the encryption method used in all three methods. Right, now let me show you where the actual data goes into. I use MongoDB to store the user credential and image history. Let me show you. Although we use Cloudinary to store the image, we only use a text data in MongoDB. Let's go to our cluster, and our project is image encryption. Browse collection. We can see all the user credential and performed history here. It sometimes takes time. Now user, we can see that all are the users that I have created previously, and this is our test case 2 that I created now for our reference, and its password is this. Although we did not keep this password, it is a secret or encrypted password. MongoDB use hashmap to encrypt the password. Even I am the developer, I cannot access the password that user has created. So this is for safety reasons. And this is our record that we history. This contain all the image history that we created. It also include the key values, like this key generated, and provide the encryption method, chaotic encryption. So these all store the user credential. Now let's go for image, where the image goes through. Images are only uploaded on Cloudinary. Cloudinary is one of the best cloud service to upload the visual content or images or videos. Now go to assets. We can see that all the images that we process through the project are uploaded here. These images we can download from here also. These all are the image. So this was my project, and thank you so much for watching this video.